Hey everyone, this is Jonathan from Chegg Tutors, and this lesson is on the Ka and the strength of acids. So what is the Ka? It's just the equilibrium constant for the dissociation of an acid in water. So at equilibrium, the forward and reverse reaction rates are equal. So what this Ka tells us is the ratio of products to reactants at equilibrium. So let's first determine how acids dissociate. So let's take a generic acid, so HA, where this is your acidic proton. So in water, this acid is going to do what acids do and donate a proton to form H3O plus and the conjugate base, A minus. So here's your acid, here's your conjugate base, and your H3O plus that's formed is essentially H plus, which is responsible for acidity. So this reaction is also reversible because this is not a strong acid, it's a weak acid, so it can go in the reverse direction. So what the Ka will tell us is how well this acid dissociates into H3O plus and A minus. So let's go into more detail about what the Ka tells us. So let's write our reaction again, HA plus H2O to give H3O plus and conjugate base. So any ordinary equilibrium is equal to the concentration of products over reactants, excluding liquids and solids. So let's write our equilibrium constant for this acid dissociation. So we'll say Ka is equal to the concentration of products, so H3O plus times A minus, over the concentration of reactants, which is just HA, because we exclude water because water is a liquid. So what the Ka tells us is the ratio of these products to this reactant. So if we have a larger Ka, that means we're more prone to form products and we're more prone to dissociate into H3O plus, which indicates that we have a stronger acid. If an acid is more prone to donate its hydrogen ion to form hydronium, we have a stronger acid. So the larger the Ka, the stronger the acid because we're forming more products, which means that we're forming more hydronium ion, which means that we have a more acidic solution. So what happens when we have a strong acid? Something that completely dissociates, like hydrochloric acid. It completely goes to H plus and Cl minus. So here we don't have a reverse reaction. The Ka is much greater than 1, which means that it completely dissociates. So we don't really care about a Ka value because it's so much greater than 1 that we know that if we have a concentration of HCl, that is our concentration of H plus because it completely dissociates into hydrogen ions or hydronium ions. So for strong acids, we don't really consider their Ka values because they're much greater than 1. But for weak acids that don't entirely dissociate, the Ka helps us determine which acid is going to be stronger, because if we have more products, we have a higher Ka, we have more products, we have more hydronium ion formed, which means that we have a stronger acid. So let's look at a bunch of weak acids and rank them from strongest to weakest. So we'll call the strongest is equal to number 1, and the weakest will be number 4. So remember, the larger the Ka value means that the acid dissociates more to form more products, which means that it likes to donate its hydrogen ion more, which means it's a stronger acid. So since hydrofluoric acid has the largest Ka value, 7.2 times 10 to the negative 4th, it will be the strongest acid of these 4. So it will get number 1. because it has the largest Ka, which means it dissociates more into products, which means it likes to donate its hydrogen ion more often, which determines the strength of an acid. So then the next strongest acid will be acetic acid here, because it's 1.76 times 10 to the negative fifth. And then the next will be carbonic acid, and the next will be HCN. So we can see the smaller the Ka, the less an acid likes to dissociate into products, which means it's a weaker acid. The larger the Ka means it's a stronger acid. So I hope this helped and taught you about Ka and the strength of acids. My name is Jonathan, and I'm on Chegg Tutors.